Okay, AGS1. We are back with 4.5. May I have more, please? The essential question today: how can inequalities be used to find solutions to real problem situations? That's just a fancy way of saying we're doing alligator word problems today. Inequalities with word problems. So, all of these problems revolve around Elvira running this cafeteria and having to crunch certain numbers that have to do with prices of food and gallons of things. So, a first problem with Elvira: milk is bought for 35 cents per carton. So I'm just going to highlight some crucial information. Oh, that's not a good highlighter for this. Let's do... Okay. 35 cents a carton for milk, flat delivery charge of $75. Elvira has a milk budget of $500. So, what is the maximum number of cartons she can buy? That word maximum means that she could buy small amounts, but we want to know the biggest amount she can buy. So it's like up to that certain number. What we're going to do for this problem is write an inequality that represents the situation and then solve the inequality. So let's say C is equal to the number of milk cartons that she orders. Now, each of those are costing her 35 cents, so this is going to be 35.35 C. But then you have to have that flat delivery charge of $75. Now, this number here, this whole thing cannot exceed $500 because $500 is her total budget for milk. So we say that this has to be less than or equal to $500 because she can spend the whole $500 or less. Now that we have an inequality that represents the situation, we're going to solve it. Remember that you just solve these the same way that you would solve it if it were an equal sign. So just pretend this is an equal sign and let it hang out there. So the first thing I would do is subtract 75 from both sides. So we get 0.35C is less than or equal to 425. Then I would grab my calculator and divide 425 by 0.35. So divide both sides by 0.35 to get rid of the multiply by 0.35. So the alligator just stays the same the entire time unless you divide or multiply by negatives. So C is less than or equal to 1214.29 rounded appropriately. So what this means, what we found, this is the number of cartons of milk that she can order before she goes over her $500 budget. So, since that's 1,214.29 cartons, that means if she was to go up to 1,215 cartons, she would be over her budget. So we're going to say 1,214 cartons at most. Next problem. The cafeteria goes through 2.25 gallons of ranch every day. Wow, that's a lot of ranch. Elvira starts the school year with 130 gallons, and she needs at least 20 gallons when she reorders. The reason for that is she has to reorder at a certain point so that 20 gallons will last until the next shipment gets there. How many days will it last before she is forced to reorder? So, once again, we are going to write an inequality for this and then solve that inequality. So, she has 130 gallons, but then every day the kids are drinking drinking ranch out of a cup, 2.25 gallons of ranch per day. So let's say that D is equal to the number of days before she has to reorder. So 130, take away, the kids are doing 2.25 every day. So this expression is her ranch level after D days of kids eating the ranch. Now, we need this to be greater than or equal to 20. Because if it gets below 20, it's too late. She can't reorder with enough time to get more ranch there. So she needs that number to be above 20 before she reorders. Because she can reorder when there's like tons of ranch left. That's totally fine. But she can't let it go below 20. So it has to be, this side has to be greater than or equal to 20. Now that we have an algebra equation, we're going to solve it up. So this 130 and this 20 are like terms. So we're going to subtract 130 from both sides. Now, remember, it's okay to subtract from both sides. That does not flip your alligator. That'll really flip your alligator. Gosh, I'm really trying to make that sign there. There we go. That stays fine. So then 20 minus 130 is going to be negative 110. But now I'm going to have to divide both sides by negative 2.25. Remember, if you ever divide or multiply both sides by the negative, that's when your alligator has to flip. So we take 110 with our calculator and divide by 2.25. That means D is less than or equal to, see the alligator flip? 48.89, and this is a rounded number. So, since these are whole days, we're just going to keep it in the whole number situation and say that she has at most 48 days before she has to reorder. Also, if we were going to look at the domain of this problem, it would start with 0 days and go up to 48 days. It can't go past 48. Next problem. Elvira orders veggie burgers. So she's ordered bulk burgers in the past, and in the past they've been $78, $72, $87, and $90. So she's going to put in a fifth order, but she can't have the average burger order go over $82. That's her average budget for burgers. How much can she spend on the fifth order? Once again, we are going to write an inequality and solve it up. So the first four orders were $78, $72, $87, $90, and then she's going to put in a fifth order. We'll call it P for patties. Now, to find the average of numbers, you just add them all together and then divide by how many there are. So since we have 1, 2, 3, 4, 5 orders, that means we have to take this entire thing and divvy it by 5. And we need this to be less than or equal to $82. 82 being the average. So, this inequality will keep the average burger order under $82. Let's go ahead and solve. The first thing we would need to do is get rid of this divide by 5. So we're going to take both sides and multiply by 5. That way these 5s cancel out. And we get 78 plus 72 plus 87 plus 90 plus P is less than or equal to, on our calculator, 82 times 5 is 410. Now, these four numbers are all like terms, so we can add 78 plus 72 plus 87 plus 90 and get 327. Sort of clean up the problem a little bit. Then I would subtract 327 from both sides. So 410 take away 327 is 83. And then you're done. That means her fifth burger order can't be over $83. It has to be under $83. $83 or under. It just can't go over $83. That's another way to say that. Cannot exceed $83. There's so many different ways to say these. Like, it has to be $83 or under. It cannot exceed $83. At the most, $83. There's so much language around it. Last one. Elvira can buy pre-made pizzas for $14.50 each. So she can order ready-made pizzas for this much each pizza. She can also choose to make them for the kitchen herself or with her staff, where she spends $44.20 on bulk ingredients and then $6.25 per pizza on labor. That's people making it. What is the least amount of pizzas she has to make for it to be cheaper to make them rather than buy them? So, like, if you think about this, if she spends $44.20 and then $6.25 to make just a pizza, that pizza costs like $50. So that doesn't make sense to make one pizza because you would just buy it for $14.50 instead of making it. So we have to figure out, if you make enough of these pizzas, at what point is it a better price to make them yourself rather than buy them for $14.50 each? Setting up the equation with these, or the inequality with these things, can be the hardest part. First of all, we're going to say P is equal to the number of pizzas. Now, she can buy them for $14.50 a piece. So that's the price of, like, pre-made pizzas. Now, we need to figure, and then if she makes them herself, they're $44.20 for base ingredients, and then $6.25 per pizza. Now, we want this to be smaller, cheaper than this, buying them herself, or just buying them pre-made. So, we want just a greater than. We need to figure out when this number is bigger than this number, because if the right-hand side is smaller, then it's less per pizza. Solving this inequality, I would subtract 625p from both sides. So then 1450 minus 625 is 825p. Haven't had to do any alligator flipping because we didn't divide or multiply by a negative. Now we're going to divvy both sides by 825 to get rid of the multiplication. So 4420 divided by 8.25 is approximately 5.36. That's a rounded decimal. So that means she needs to make at least 5.36 pizzas to get that number over. So I would say she probably has to make 6 pizzas. So, because you can't really make 0.36 of a pizza. That means on the 6th pizza, it makes more sense for her to make them herself. Interval notation. That means that she has to make at least 6, but she can make over 7, 8, 9, all the way up to infinity. So, the domain of this problem is that for her to make it more sense for her to make them herself, they have to start at 6, and she can make an infinite amount of pizzas. Sounds like a dream I had once. Okay, you guys, that is it for today. There's one more problem in the Go formative that has to do with salads. It's a little bit of a doozy, but I wanted one in there that you guys could work on yourself. Good luck.